All right. Still chapter 40, Thermoregulation. This is a process by which animals maintain their internal temp within a tolerable range. You have biochemical and physiological processes that are temperature sensitive. For example, hemoglobin is less effective at binding to oxygen at higher temperatures. And then you have things with membrane fluidity too that are going to change with temperature. You can split animals into two different types. You have endotherms and ectotherms. Endotherms are mostly warmed by the heat from metabolism. And ectotherms gain their heat from their environment. So these are things like birds, mammals, and this is pretty much everything else. Amphibians, lizards, snakes, turtles, many fish, most invertebrates. These guys are going to require less food, which means these need more. They're going to adjust body temp by behavior, like seeking shade or basking in the sun. There's two other terms we need to talk about. These are for variations in temperature. A poikilotherm is an animal whose body temp varies with environment. A homeotherm has relatively constant temp. But this is not necessarily the same as endotherm and ectotherm. Some ectothermic fish live in environments with stable temperatures, therefore they're homeotherms. And then you have things like bats and hummingbirds that enter inactive states in which they maintain a lower body temperature. When you were little, you were probably taught cold-blooded versus warm-blooded. Those are not scientific terms. Do not say them. An ectotherm on a hot day could have much warmer blood than you do. Just not good terms. Be smart. Balancing heat loss and gain. Organisms, like objects, exchange their heat in four ways: radiation, evaporation, conduction, and convection. Heat is always transferred from an object of higher temperature to an object with lower temperature. And in mammals, most of these mechanisms involve the integumentary system, which is your skin. Insulation reduces... Hang on. You know me, I can't read my notes. Insulation is going to reduce the flow of heat between an animal and its environment. This is things like hair, feathers, and fat. And then critters with fur or feathers can raise those feathers when they're cold, trap a layer of air there. You lack this, but your goosebumps are a vestige, like a vestigial organ, a vestige of raising hair from your ancestors. Since you don't have fur or feathers, you rely on fat. Many marine animals have a very thick layer of fat called blubber. And it's so good at insulating them that even though they're in freezing waters like a walrus or a big whale, if they're in freezing water with ice around them, they can still maintain a 36 to 38 degrees Celsius temperature. And they do it without more food requirements than land animals of equivalent size. Obviously, there's not whales, just heads up. Circulatory adaptations. Animals can regulate the amount of blood flow between the core and the skin. Vasodilation is the widening of superficial, or close to the surface, superficial blood vessels. And you can see this in old walruses are lighter in color than young. And so by the time they're very old, they're pretty much white. And in the water, they're white. But when they jump out on land, they are like bright pink once the blood starts flowing closer to their skin. And they're heating themselves up with the sun. Circulatory adaptations are things like a counter current exchange. Yeah, there's an N in there. This is transfer of heat or solids between fluids that are flowing in opposite directions. So between the artery here, going away from the heart, and the vein going towards, you're passing heat. And this happens in birds' legs, so that if they're standing in cold water, they're not losing all their heat to the water. And then the same thing is happening here, in the dolphin's fins. Don't go to sleep. Some fish and sharks and insects keep, fish and sharks are going to keep their swimming muscles warmer than the skin at the surface to allow them to swim farther and faster. And insects will keep their thorax warmer where flying muscles are. Cooling by evaporative heat loss. Evaporation is the only way to lose heat. You have, or it's not the only way. Anyway, evaporation is the only way to keep body temperatures from rising. That's what I mean. All right. Panting is the way this happens. Birds have a pouch in their mouth with lots of blood vessels, and fluttering that pouch helps them to release heat. And then sweating in terrestrial mammals, sweat glands, or even bathing, like birds in a bath, will enhance evaporative cooling. Behavioral responses can be simple, like moving to cool areas, or moving to warm areas, or extreme, like migration and hibernation. With behavioral response, we also have desert locusts and other types of animals that our desert locusts have to reach a certain temperature to become active, and the desert locusts and other types of insects actually have positional or poses that they get into to try to warm up faster. Honeybee, they depend on social behavior. When it's cold, they huddle together and they move from the colder edges into the warmer center. They also use honey as fuel, and when it's hot, they carry water into the hive and fan their wings to promote evaporation. Adjusting for metabolic heat production. Endotherms can vary on heat production. Thermogenesis. This is to match rates of heat loss. You have a couple of possibilities. If you need to make heat, you can move, or you can shiver. Shivering makes you warmer. Non-shivering thermogenesis, in some mammals, you have brown fat. Sounds lovely. In humans, it's found between the neck and the shoulders. In infants, it accounts for 5% of body weight, and it's recently been found in adults. And it's higher when outdoor temperature is colder. You have more brown fat. Some reptiles, like large reptiles like the Burmese python, they can be endothermic in particular circumstances, which leads to the idea that some dinosaurs may have been endothermic. Acclimatization and thermoregulation, birds and mammals. In birds and mammals, seasonal temperature changes include adjusting insulation. So they'll have thicker coats of fur in the winter and shedded in the summer. Cells produce variants of enzymes that have the same function but work at different temps. And then you have differences in your membrane structure, the percentage or proportion of unsaturated fats to saturated fats. Some ectotherms, when exposed to sub-zero temperatures, can make something called an antifreeze. Wow. Compound to prevent ice forming in their cells. Physiological thermostats and fever. In humans, the hypothalamus controls thermoregulation. But if you get a viral or bacterial infection, you get a fever, you get elevated body temperature. And it's like your body has an increase in the set point for that temperature. And it's in response trying to mess up the metabolism of those critters as well. One more.